There and welcome. We are going to do this video on solving multi-step equations. You should be in your pre-algebra quarter one notebook on page 37. In our last lesson, we talked about using stay and go to solve two-step equations. We're now going to use stay and go and solve some multi-step equations. And you're really going to see how this method can help you make sense of these multi-step equations. So I'm going to go look at number 4. And what I notice, the difference here between the ones we did the other day, in each of these equations, I only have one term that has a variable, right? Well, in this particular problem, I have a term with a variable on the left and a term with a variable on the right. Let's use stay and go to make that work for us. I'm going to draw the line, separate my left from my right. I know that I want my variables to be on the left, and I know that I want my constants to be on the right. Let's look term by term and see, should they stay or should they go? This is a 5x. It's a term with a variable. It's on the left, and I do want my variables to be on the left, so it will stay. This negative 7x is on the right. I don't want variables on the right. I want them on the left, so this needs to go. And now I have a plus 24. It's a constant, a number all by itself. It's on the right. I want it to be on the right, so it's going to stay. When I write this now, term by term, this stays. Remember the first rule, if a term stays, the sign stays the same. This is a plus 5x, so it will stay 5x. Rule 2, if the term goes, the sign will change to its opposite. This negative 7x is going. It's a negative 7x. The opposite is plus 7x. So when I move it over, it becomes a plus. That equals a plus 24. It's staying, so it's going to stay plus 24. Alrighty, so I'm going to combine my terms. I've got 5x plus 7x. 5 plus 7 is 12x, and that equals 24. And look, I'm back to a one-step equation where I see that I have 12 times x. I'm going to use my inverse operation, which is division. I'm going to divide both sides by the number with the variable 12, and x equals 24 divided by 12, which is 2. Alrighty, let's move on to page 38 and see how stay and go helps us when now I've got term with a variable here, term with a variable here, constant here, constant here. Let's use stay and go. It's going to make it all make sense. So variables over here on the left, constants over here on the right. This is a 6x. It's on the left. Number with a variable. It's going to stay. This is a plus 22. That is a constant. I need that to be on the right. It's going to go. This negative 3x is over here on the right. I need it to be on the left. It's going to go. And this plus 31 is over here very happily on the right. I want it on the right, so it will stay. As I write this down, remember, if the number is staying, the sign stays the same. If it's going, it changes to its opposite. So I have a plus 6x. It's staying, so it's going to stay a plus 6x. This plus 22 is going. It's going to change to negative 22. This negative 3x is going to go. Because it's going, it's got to change to a plus 3x. And this plus 31 is going to stay, so it is going to be plus 31. Now I'm going to add and subtract a little. I've got 6x plus 3x, 6 plus 3, that is 9x. And I have negative 22 plus 31. If you put that in your calculator, you're going to find that you get 9. Back to that same place where I have 9 times the variable x. Use my inverse operation and divide both sides by the number with the variable, and I have x equals 9 divided by 9, which is 1. I have solved my first multi-step equation. Let's move on to number 6 and see if it's still working. Alrighty, I drew my line. I've got my left, I've got my right. This time I'm not going to write variable and constant up there. I'm going to try and make sure I can do it without those. But if you still want to write V and C, please by all means do so. This is a number with a variable. It's on the left. I want it to be on the left, so it will stay. Plus 6 is a constant. This needs to be on the right, so it's going to go. 21 is a constant. I want my constants on the right, so it will stay. Negative 6x is a variable. It needs to be on the left. It's going to go. When I write this, I've got 3x. It is staying, so it will keep the sign. The sign stays the same. This plus 6 is going, so it changes to the opposite, minus 6. This 21 is staying. It's a plus 21, and it stays plus 21. And the last term is minus 6x. It's going, so it will change to its opposite of minus 6x, plus 6x. Alrighty, got some adding and subtracting to do. 3x plus 6x, 3 plus 6 is 9x. And I have negative 6 plus 21. If you put that in your handy dandy calculator, you will get 15. Okay. Happily, I'm back at that same place again. I've got 9 times x. So I'm going to divide, use that inverse operation, divide both sides. And lo and behold, I'm going to put 15 divided by 9, and I'm going to find it is not a whole number. Not a whole number. So keep the fraction. Let's get used to using those fractions. So I'm going to put this as 15 over 9. I do have to make sure it's fully simplified. So I know that I can put 3 into 15 and 3 into 9. So x equals 15 divided by 3, which is 5. 9 divided by 3, which is 3. X equals 5/3. Moving on. Next one, draw the line. Remember, variables on the left, constants on the right. Should I stay or should I go? That's what we need to know. I got 7. That's a constant. Constants need to be on the right. It is going to go. Negative 6x, that is a number with a variable. I want that on the left, so it will stay. 2x, it's over here on the right. I want it on the left, so it's going to go. And plus 3, that is a constant. I want it on the right. It's going to stay on the right. When I rewrite this, put my equal sign there. This plus 7 is going, so it's going to change from a plus 7. When it goes, it changes to the opposite, negative 7. This negative 6x is staying. When it stays, the sign stays the same, so I got minus 6x. 2x is going, because it's a plus 2x and it's going to change from a plus 2 to a minus 2x. And this plus 3 is staying, so it will keep the same sign, and that is plus 3. Alrighty, when I combine those like terms, negative 6 minus 2. Put that in a calculator, negative 6 minus 2, and you will get negative 8x equals negative 7 plus 3, negative 4. Okay, multiplication. Use that inverse operation. Negative 8, negative 8. X equals, that's not going to be a whole number either. I think you're going to find if you put negative 4 divided by negative 8, not a whole number. So, keep as a fraction. Don't forget, keep those as a fraction. So I have a negative divided by a negative. I know that's going to be positive. So I have 4/8. I can simplify this. I can divide both the numerator and the denominator by 4, and x will equal 4 divided by 4, which is 1, and 8 divided by 4, which is 2. X equals 1/2. Okay, we're going to do one more in this video. This is number 8. It is let's just start with the stay and go first. So the first thing is, I know we're all going to be very uncomfortable with this fractional exponent, but don't worry, we got this. I am going to take that line and separate my left from the right. I want my numbers with the variables on the left, my constants on the right. This is a number with a variable. I know it's a fraction, but it's still a number with a variable, so it's going to stay over here on the left. This minus 1 is a constant. It needs to be on the right, so it will go. And this 11 is a constant. It's over here on the right, and it's going to stay. So I've got 2/3 x. It's staying. -1 is going, so the sign will change to the opposite. The opposite of -1 is a +1. And 11, a +11 is staying, so it stays the same sign. I am going to add, and I get 2/3 x equals 1 plus 11, which is 12. So now I'm in a bit of a situation. I know this is multiplication, right? So I know that I want to divide, but dividing by a fraction can be very uncomfortable, right? What I want you to know is that when I divide by a fraction, it is the same thing as multiplying by the reciprocal. And actually, in fact, there's a property in algebra that tells me anytime I multiply a number by its reciprocal, the answer will be 1. So since I want to get 1x, if I multiply by the reciprocal or the flip, 3/2, that will actually equal 1, and I will cancel out that coefficient. Let me show you what that looks like. I had 2/3, right? And I multiplied it by 3/2. That's a reciprocal. Reciprocal. When I multiply straight across. Oh, there's Piper. Sorry, I'm going to pause it really quickly since she's very feisty. So when I multiply straight across. 2 times 3 in the numerator, that's 6. 3 times 2, I multiply straight across in the denominator, that is 6. What is 6 divided by 6? Well, any number divided by itself is 1. So you can see that this equals 1x. And guess what? 1x is just x. Yay! So that's why I multiply by the reciprocal. A little trickier, of course, there she goes again. By 3/2, gonna pause it. Okay, I'm back. I think Piper has stopped barking. So now I have a situation where I'm multiplying a whole number times a fraction. This is what I want you to do. I want you to put the fraction in the calculator first. Remember, fractions are division, so it's just simply 3 divided by 2. Okay? 3 divided by 2. And you're going to find out that it equals 1.5. Now, you're going to multiply directly, just in the calculator, all in one time, by 12. And that, my calculator does a little fancily, is 18. But here is what, if you have your calculator with you right now, 3 divided by 2 times 12. See how I put it in one line? Yours will come out as 18. It's really important to put that calculator first. That's what I want to highlight. Now, if you want to see the mathematical stuff behind multiplying these fractions, if I have 12 times 3/2, right? When I multiply fractions and I have a whole number, I always put a 1 under it. Then I multiply straight across. Numerator, 12 times 3 is 36. Denominator, 1 times 2 is 2. Fractions are division. 36 divided by 2 equals 18. So you can see how we get it using fraction multiplication, but you can certainly use a calculator. The only thing is make sure the fraction goes into the calculator first. Alrighty, that's it for this video. I am actually going to do a separate video where we do question 9 and 10. So get ready for that exciting viewing video.